Most of us remember wavelength as a static line in a textbook. It's usually a thin, mathematical curve with arrows measuring the distance between two peaks. In the physical world, that distance represents the scale of kinetic energy. These waves are actual vibrations moving through space, exerting a measurable force on the matter they encounter. To process this energy without being overwhelmed, human biology operates through a specific filter. We have sensors tuned to specific frequencies, while the rest of the environment remains undetected. Even in a quiet room, you are submerged in an ocean of these frequencies. There are radio signals, thermal signatures, and cosmic radiation constantly passing through your body. Because our senses ignore the vast majority of these waves, the reality we experience is defined by our biological boundaries. We see these boundaries clearly in sound. Acoustic waves require a medium like air to move, and because they displace that medium, the waves have literal physical dimensions. A 20 Hz sub-bass tone generates a 17-meter wave, the height of a 5-story building. This massive footprint passes through concrete, explaining why you feel a neighbor's bass. A 10,000 Hz tone creates a 3.4 centimeter wave, the size of a mosquito, which shatters against thin glass. In sound, the physical length of the wave determines both the pitch we hear and how that energy interacts with the solid world. Electromagnetic waves follow the exact same principles of scale, but they operate without a physical medium. These waves are synchronized oscillations of electric and magnetic fields, traveling at high speed through the absolute vacuum of space. Our visual system acts as a highly restrictive biological bandpass filter. We only possess receptors for wavelengths between 380 nanometers, known as violet, and 700 nanometers, known as red. Visualizing the electromagnetic spectrum as an 81-octave piano keyboard, the portion humans see occupies just one single key, a mere 0.0035%. The endless remaining keys represent radio, microwaves, and thermal energy, all playing at once, completely invisible. In 1800, William Herschel proved this hidden reality existed by placing a thermometer just beyond the red edge of a prism spectrum. The temperature rose, revealing infrared radiation, a type of light he famously described as unfit for vision. This means that radio signals and X-rays are functionally identical to the light we see. They are simply colors that exist outside our biological range. Based on these numbers, the visible spectrum is a narrow window that hides a vast reality of energetic activity. Other creatures occupy different sections of the spectrum, tuning into channels of reality that remain closed to us. Reindeer avoid electrical power lines because they can see the ultraviolet light these cables emit. While a human sees a harmless wire, a reindeer sees a series of frightening, high-energy flashes across the sky. Predators like snakes and mosquitoes hunt by tracking infrared radiation. They locate prey by sensing the body heat radiating through the environment. Astronomer Carl Sagan believed that our worldview changes when we understand the science of these hidden wavelengths. He noted that a red sunset becomes more stirred when we realize we are watching the atmosphere scatter specific wavelengths of white light. The beauty is heightened by our understanding of the physics involved. We are constantly surrounded by a dense and chaotic reality that our brains are evolved to ignore. If you could expand your own biological filter today, which wavelength would you choose to see? Would you want to observe the heat signatures of infrared or the ultraviolet patterns hidden on a flower? Scientific analysis reveals the specific mechanics of a cosmos that is far more expansive than our eyes suggest.